final part of electrical engineering previous year question paper with a detailed solution of Isro-Vssc technical assistant exam held in 2016. Advertisement in number 291 and post number 1285. Up to question number 60 we discussed in the last 3 videos. Question number 61. In a microprocessor, opcode fetch cycle answer is option B, first part of instruction cycle. The time required by the microprocessor to complete an operation of accessing memory or input-output device is called machine cycle. The 4 steps involved in machine cycle in order is: first one is the fetch, second one is the decode, third one is the execute, and fourth one is the store. In execution of any instruction, first cycle is opcode fetch. After that, depending upon the given instruction, the memory read or write and IO read or write cycle occurs. Question number 62. Integral sin x dx is answer is option D, minus cos x plus c. The c is a integration constant. The additional points are integration of cos x dx equal to sin x plus c, integral sec square x dx equal to tan x plus c, integral sec x tan x dx equal to sec x plus c, integral cosec x cot x equal to minus cosec x plus c, integral cosec x square dx equal to minus cot x plus c, d by dx of sin x equal to cos x, d by dx of cos x equal to minus sin x, d by dx derivative ആണ്, d by dx of tan x equal to sec square x, d by dx of sec x equal to sec x tan x, d by dx of cosec x equal to minus cosec x cot x, d by dx of cot x equal to minus cosec x. Next question 63. A synchronous generator connected to an infinite bus delivers power at lagging power factor. If its field excitation is increased, what is the effect? Answer is option C, current delivered increases. Synchronous generator. A synchronous generator or alternator is capable of operating at all types of power factor, that is either unity power factor, leading or lagging power factor. Leading power factor. If field excitation is such that EB less than V, the alternator is said to be under excited and it has leading power factor. We can understand this from this diagram. In x-axis it is IF and in the y-axis armature current, unity power factor, lead section and under excitation and over excitation, full load, half load and no load variations. From this diagram, lagging power factor. If field excitation is such that EB greater than V, the alternator is said to be over excited and it draws lagging current. Unity power factor. If field excitation is such that EB equal to V, the alternator is said to be normally excited. Question number 64. The Faraday effect on long overhead lines is experienced when answer is option A, the line is slightly loaded. Faraday effect. The effect in which the voltage at the receiving end of the transmission line is more than the sending voltage is known as the Faraday effect. Such a type of effect mainly occurs because of the light load or open circuit, that is no load at the receiving end. Faraday effect occurs when the current drawn by the distributed capacitance of the line itself is greater than the current associated with the load at the receiving end of the line, that is during light or no load. This capacitor charging current leads to a voltage drop across the line inductor of the transmission system, which is in phase with the sending end voltages. This voltage drop keeps on increasing additively as we move towards the load end of the line, and subsequently at the receiving end, voltage tends to get larger than the applied voltage, leading to the phenomena called Faraday effect in the power system. Thus, both the capacitance and inductor effect of the transmission line are equally responsible for this particular phenomenon to occur, and hence Faraday effect is negligible in the case of short transmission line, as the capacitance of such a line is practically not considered. In general, for a 300 km line operating at a frequency of 50 Hz, the no-load receiving end voltage has been found to be 5% higher than the sending end voltage. Faraday effect is not a problem for short transmission line because there is no capacitance effect. Question number 65. Which is the most serious problem in vacuum circuit breaker? Answer is option C, current chopping. Current chopping in circuit breaker is defined as a phenomenon in which current is forcibly interrupted before the natural current zero. The voltage across the capacitor during current chopping is I square L by 2, which is equal to CV square by 2. After rearranging, we get V equal to 1 by root of L by C. Current chopping is mainly observed in the vacuum circuit breaker and air blast circuit breaker. There is no such phenomenon in oil circuit breaker. Question number 67. The illumination required for a workplace where fine work is performed will be of the order of. Answer is option C, 1500 lumens per square meter. The other cases are for general offices, illuminance is 500. For computer workstation, factory assembly areas, the illuminance is 500. For rough work, the illuminance is 300. For medium work, it is 500. For fine work, the illuminance is 750. For very fine work, the illuminance is 1500. For instrument assembly, the illuminance is 1000. For jewelry assembly or repairs, it is 1500. For hospital operating theatres, the illuminance is 2000 to 10,000. Therefore, illumination required for a fine work is of the order of 1500 lumens per square meter. Question number 68 is cancelled due to insufficient data, or the option given is wrong. So consider question number 69. In an SMPS operating at a 20 to 100 kHz, what is the main switching element? Answer is option B, MOSFET. The switched mode power supply owes its name to the DC to DC switching converter for conversion from unregulated DC input voltage to regulated DC output voltage. The switch employed in is turned on and off, referred as switching at a high frequency. At a high switching frequency of the order of 100 kHz and a fast control over the duty ratio results in application of the desired mean voltage along the ripple voltage of a very high frequency to the output side. MOSFETs are preferred in those applications with high frequency operations. MOSFET applications include switch mode power supplies using hard switching. Question number 70. Question number 70. Between a 100 volt DC source and a 0.1 inductive load, a thyristor is used to control the load. The latching current of a thyristor is 100 milliampere. What is the minimum pulse width to be applied to the gate of the thyristor to turn it on? Answer is option A, 100 microsecond. The voltage equation for inductive load SCR circuit is E equal to L di by dt. From here we can derive the value of di equal to E by L dt. Take integration on both sides, we get I equal to E by L t, where E is the source voltage and I is the latching current and T is the pulse width. Here the values given are E equal to 100 volt, L equal to 0.1 Henry and I is the 100 milliampere. Therefore, minimum pulse width of the gate pulse required to properly turn on SCR, T equal to, after rearranging the equation 1, we get T equal to L by E into I. Substituting the values of L, E and I, we get T equal to 100 microsecond. Question number 71. Typical value of filter capacitor for 50 Hz rectifier is option A, 1000 microfarad. A capacitor is included in the rectifier circuit to act as a filter to reduce ripple voltage. Typical value of filter capacitor for a 50 Hz rectifier is 1000 microfarad. The important property of a capacitor is that it passes the AC signal but blocks DC signal, and hence a capacitor is used in the rectifier circuit. The reactance of the capacitor is Xc equal to 1 by j omega c, where omega is the angular frequency and c is the capacitance. For the DC signal, omega equal to 0, so the Xc is infinite. For the AC signal, let us assume W equal to W1. Now if W1 is large, then Xc will be small, so that impedance will be low. Hence AC signal will pass through the capacitor, but it blocks the DC signal, so that it reduces the ripples in the rectifier circuit. This figure shows the full wave rectifier DC output voltage, and the second one shows the rectifier DC voltage with the filtering, that is after using the 1000 microfarad capacitor. The fundamental frequency of the ripple frequency is twice that of the AC supply frequency 100 Hz, where for the half wave rectifier it is equal to the supply frequency 50 Hz. Question number 72. In the given figure, Steady state current through 2 ohm resistor. Answer is option B, 0.9 ampere. At a steady state condition, the capacitor behaves as an open circuit. So the modified circuit is like this. Applying nodal analysis at node VA, we get VA minus 6 divided by 2.8 plus VA by 3 plus VA by 2 equal to 0. After rearranging, we get VA equal to 1.8 volt. The current flowing through 2 ohm resistor I equal to VA by 2. After substituting the value of VA, we get I equal to 0.9 ampere. Question number 73. In the figure R equal to 1 ohm, what is the value of I? Answer is option B, 1.5 ampere. From the diagram, we can combine the last R and R which is in series, which is equal to 2R. Applying nodal analysis is that VA is in the circuit is modified. We get VA minus 6 divided by R plus 2A by 2R plus VA by 2R equal to 0. After solving, we get VA equal to 3 volt. Therefore, current IA equal to VA by R. We get 1.5 ampere. Question number 74. In a HTML page, apart from B tag, which of the following make the text bold? Answer is strong. In HTML, the following two syntax are used to make the text bold: B and strong. EM tag is used to define emphasized text. The content inside is typically displayed in italic. Consider the representation of 6-bit numbers in 2's complement, 1's complement and sign and magnitude format, in which representation the addition of integers 0, 1, 1, 0, 0, 0 and 0, 1, 1, 0, 0, 0 will result in an overflow. Answer is option D in all three. First, consider addition of integers in 1's complement. 1's complement of 0, 1, 1, 0, 0 is 1, 0, 0, 1, 1, 1. Addition of number 1, 0, 0, 1, 1, 1 plus 1, 0, 0, 1, 1, 1 give the answer of 1, 0, 0, 1, 1, 1, 0. Therefore, in this 1, 0, 0, 1, 1, 1, 0, the digit 1 in the MSB is an overflow. Therefore, in addition of integers in 1's complement, their overflow occurred. Addition of integers in 2's complement. 2's complement of 0, 1, 1, 0, 0, 0 is 1, 0, 1, 0, 0, 0. Addition 1, 0, 1, 0, 0, 0 plus 1, 0, 1, 0, 0, 0 equal to 1, 0, 1, 0, 0, 0, 0. Therefore, in this 1, 0, 1, 0, 0, 0, 0, the digit 1 in the MSB is an overflow. Question, the addition of integers in sign and magnitude format. In sign and magnitude format, if MSB is 0, that means given number is positive, and if MSB is 1, that means given number is negative. So given number 0, 1, 1, 0, 0, that is the same number, that both numbers are same, which are positive. Therefore, addition of 1, 1, 0, 0 plus 1, 1, 0, 0 gives 1, 1, 0, 0, 0, 0. Therefore, in this 1, 1, 0, 0, 0, 0, the digit 1 in the MSB is an overflow. Conclusion: overflow will occur in all the three cases. The supply voltage to an induction motor is reduced by 10%. By what percentage approximately will the maximum torque decrease? Answer is option A, 20%. Tmax directly proportional to E2 square directly proportional to V square. We know Tmax equal to, that is torque maximum, equal to 180 divided by 2 pi ns into E2 square divided by 2x2. That is Tmax equal to K into E20 square divided by 2x20. Tmax new equal to Tmax old into 0.9 square divided by 1 square. We get 0.81 Tmax old. Reduction in torque equal to 1 minus 0.81, which is equal to 0.19. Hence, maximum torque decreased by, that is 0.19 into 100, approximately 20%. Question number 77. The input to a 3-phase induction motor is 50 kilowatt. The stator losses amount to 800 watt. The rotor copper loss per phase is, slip is 3%. Answer is option B, 492 watt. Given stator input power P equal to 50 kilowatt, stator loss equal to 800 watt, slip S equal to 3%, which is equal to 0.03. Rotor input or air gap power P equal to stator input power minus stator loss. Substituting the values of stator input power 50,000 and stator loss as 800, which is given in the question, we get a rotor input or air gap power P equal to 49200 watt. Therefore, rotor copper loss PCU equal to S into P in question. They given slip S equal to 0.03 into and we get P in equal to 49200. After substituting these two values, we get rotor copper loss equal to 1476 watt. Then rotor copper loss per phase is PCU divided by 3. In question they given it is a 3 phase. Therefore per phase equal to PCU divided by 3. 1476 divided by 3, we will get an answer of 492 watt. Question number 78. The no load speed of an induction motor depends on. Answer is option D, only A and B, that is the supply frequency and the number of its poles. The synchronous speed Ns equal to 120 F by P, where F is the frequency and P is the number of poles. The induction motor rotates at a speed Nr close but less than the synchronous speed. Slip of an induction motor S equal to Ns minus Nr divided by Ns, where Ns is the synchronous speed, Nr is the rotor speed. At no load, rotor speed is approximately equal to synchronous speed. So that no load speed of an induction motor depends on supply frequency and number of its poles. Question number C. Which of the following material have negative temperature coefficient of resistance? Among the given option, carbon has a negative temperature coefficient of resistance. Temperature coefficient of resistance explains the variation in the resistance by the change in temperature. If it is positive, resistance increases with an increase in temperature. If temperature coefficient of resistance is negative, resistance decreases with an increase in temperature. A conductor has positive temperature coefficient. Corresponding graph will like this. And a semiconductor have a negative temperature coefficient. And the corresponding graph of a semiconductor is like this. The final question of this video and this section is 80th one. For a sinusoidal waveform, form factor is, answer is option A, 1.11. The form factor is defined as the ratio of the RMS value to the average value of an alternating quantity. Form factor equal to RMS value divided by average value. Crest or peak factor is defined as a ratio of maximum value to the RMS value of an alternating quantity. Peak factor equal to maximum value divided by RMS value. For a sinusoidal waveform, form factor equal to 1.11 and peak factor equal to 1.414. Thank you.